In previous discussions we talked about load input voltage and load voltage. So this is input voltage and load voltage. So from alpha to pi plus alpha T1 and T2 conducts, and from pi plus alpha to next pi plus alpha onwards T3 and T4 conducts. In load side it will same output voltage is received. Okay. Now we need to talk about this load current. Why we have shown this load current is like a constant, means it is having a little variation. We have shown it as almost constant. We will talk about that right now. Again I will go back to simulation. So you can see here the load, this is my circuits. We are measuring a load current somewhere here, load side current. See here, the load current is 0 exactly before a fire T1 and T2. The load voltage increases like this, the load current slowly increases. As I told, current is lagging behind the voltage. The load voltage reaches to 0 here, but load current is little, it has reduced, but it not reached 0. It is somewhere here 20 amps. And later the load current reduced, but little bit it reduced. Then again next off cycle starts, then again load current increased. What I am saying here, the load current is not reaching to 0. One main thing. In this particular case, sometimes it may reach to 0. In discontinuous case, as I told, sometimes this may reaches to 0 if the inductance is small and resistance is high. One main important thing is the load current is lagging behind the voltage. For a highly inductive load, the load current will not reach to 0 and it will change like this. Okay, this is transient stage output, means in the starting cases it will change in this way, and finally how it looks like, that we need to show. So I will simulate this for a till 1000 milliseconds in the sense, so here we'll run here. You can see here the load current has increased and it has reached almost constant. See, there is a variation in the load current, but if you compare to average time, see this is very small. If you compare this height and this value, this whatever ripple, whatever I can say that these are the current ripples, the changes in the current value is very small compared to its average value. If you take the average, we need to take somewhere here midpoint of that. This average current is very high compared to ripple of that current, so that I can approximate this as like a straight line, means I can say that the load current is constant. The load current is constant. if you place an highly inductive load like a DC motor in a load side, the load current is almost constant. Strictly speaking, it varies like this, but approximately I can show this like a straight line, as I have shown in this. Rashid has shown this as a straight line. So this is my next slide. Here he has shown it as a straight line. So why this is straight line? This is an approximation. Yeah, the load current is consisting ripples, but that ripple is very small. I am neglecting that just for simplicity, and I am drawing it like a straight line. So it holds good, because you can see here the load ripple is very small, very small. Okay, so this is almost like I have shown it as a straight line. So this is the reasons. See, one main thing we need to remember here onwards is this point. Okay, I am assuming that here onwards the load current of the fully controlled rectifier is a straight line when the load is highly inductive DC motor, highly inductive load like DC motor. Okay, this is my load current. I think this doubt has been answered why this is straight line. The next, we need to measure the currents in a source side. In a source side, remember, if I keep my arrow somewhere here, this is load current arrow. Load current arrow. If this load current arrow, so as I shown here is like this load current arrow. So this is source current. See, if you compare to this arrow, in positive half cycle the load is current is flowing this way, correct? So means in positive half cycle current is flowing in this way. It comes from here, it comes from here, it comes from here, it comes from here, it goes in this way, 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 positive half cycle. So if I show the output current I naught here with this arrow, with this arrow, with this arrow, this arrow and this arrow, if I compare the current which is actual current arrow, it is same. So I am saying that load current is positive in positive half cycle. And again in the negative half cycle, what happens? This side becomes positive and this side becomes negative. The current will come here, current will come here, plus, current flows in this way, current flows in this way, current flows here, flows here, flows here, flows here, flows here, and it flows in this way. So this is the arrow. See, this arrow, if you compare now, this arrow, if you compare this arrow and this arrow is in same. So in the negative half cycle also load current is positive. That's the reasons the load current from alpha to pi plus alpha is also in same direction, and pi plus alpha to later also it is in same direction. So load current is in magnitude wise it is positive always. Next, we need to talk about source current. See, assume that here onwards the source current I will say, I will assume that I will write an arrow like this and I will call this as a source current IS. In positive, if this is my arrow, means I am measuring source current with respect to this arrow. if if the current is flowing same in the arrow direction, I will say it is positive. At any time if actual current is going opposite to this arrow, I will say it as a negative. Always positive negative of current is depending on the arrow what we are considering for reference. For reference I am considering this is my reference right now. I am considering this is positive. Okay, if you consider this arrow will trace in the source side how current flows. In the source side, in the positive of cycle, this is plus and this is minus. The current is moving in this way, current is moving in this way, current is moving in this way. Okay, it flows like this, flows like this, flows like this, flows in this way, flows in this way, flows in this way and this way. So current direction, I can say this is actual current flow. This arrow and this arrow, IS arrow, if I compare it is positive, means I will say it is in the same direction. So from alpha to pi plus alpha, source current is like this. The next question, okay, the magnitude wise it is same as load current. Why? This magnitude and this magnitude is same. Why? Whatever current it is flowing here, it is flowing to load side. Load side current magnitude we have shown as IA, means the same current is coming here from here, so it is same. So load current and source current is in series, correct? No, it is in the same path. So whatever load is receiving, it is coming from source. So source current value is also same as my load current value. Next, from here to here what happens, that is very important. So from here to here, see this side is plus. I can show you using some other ink. This side is plus at that time, okay, and this side is minus. The current will come in this way, it comes in this way, comes in this way, comes here, comes like this. So it flows in this way, flows here, flows here, flows here, flows like this, flows like this, flows like this, like this, like this, like this, like this. The arrow actual flow direction is in this way, correct or not? It is actual flow direction is in this way. Current always flows from positive to negative. Current direction flow is in this way. Current direction flow is in this way, correct or not? Yeah, it is in this way. Then it goes in this way. So it likes this. If you compare this arrow and this arrow, means we have measured the IS with respect to this arrow. The actual current which is flowing in negative half cycle is opposite to this arrow. That's the reason I show this load current in this way. So I think I clarified why I shown the source current as load current like this. And I am assuming now the load current is constant. That's the reason source current is also constant like this throughout this one cycle. So I will repeat now. T1 and T2 conducts in positive of cycle. So T1 starts at alpha, it conducts till pi plus alpha. As soon as you fire T3 and T4, T1 and T2 will turn off automatically. That is called natural commutation. And T3, T4 starts conducting. The load voltage, whatever we are delivering, it looks like this. And this is my load current, this is my source current. Remember now, if you compare this side, see here, So this area you can see input is positive here, entirely it is positive, it is entirely positive. So here onwards, I can say from alpha onwards, see alpha onwards, my input is positive. Correct? Input voltage is positive. Load current, so input current is positive. So the power is positive, means the input voltage and input current, if you take product of that, it gives you power. The power is positive means in this range till alpha to pi, from alpha to pi, meaning here is the power is delivered to load from source. The power flow is from source to load. Then so power flow is from source to load. I can say that this is my source side, this is my load side. Power flow is from source to load. Power flow is from source to load. Okay. Next. From pi onwards, what happens? Here, so we'll see what is the power. So this side you can see here, the input voltage is in negative right now. Right now it is in negative. This input voltage, it is in negative. So I can show you here, this point is negative, so this area is negative. This area. This area is, right now it is negative. Then what about load current, input current? This area is positive, means what is the meaning? The product of this is, one is negative and another one is positive. Negative, the power is negative, means what is the meaning? The power is delivered from load to source. Power flow is from load to source. The inductor energy is given to source. This is the meaning. So right now what we do in after pi, so power flow is in ultra direction. So power flow is in this way, from pi to pi plus alpha. The power flow is from load to source. This is very important. That's the reason we call it as a two-quadrant converter. Two-quadrant converter. Okay, thank you. This is very useful in controlling the speed of a DC motor, So, two-quadrant operation is possible here. So, load voltage can take, see if it is, if you feel that we are fired at some very high firing angle, what happens here? See, the voltage starts somewhere here, the voltage starts here like this, and it continues in this way, it continues like this, and it flows till this side, and like this. We need to assume that the inductor is a high value. In this side, if you take an average of that, then the negative is more, positive is less. So if you come back to this formula, if cos alpha is more than 90 degree, what is the value of cos alpha? More than 90 is -1. So I can deliver negative voltage to load also. See here, this value can take negative also when alpha is more than 90. That's the reasons we say that this is a fully controlled rectifier. We can deliver positive voltage to load as well as we can deliver negative voltage to the load also. So load voltage can take positive or else negative also. So this is the beauty of this fully controlled rectifier. So this works. From alpha to pi, we call this as a rectifier mode, and from pi to pi plus alpha, we call this as an inverter mode. In a rectifier mode, the power flows from source to load. In inverter mode, power flows from load to source. Thank you. Please read Rashid for more informations.